Hello and welcome to this section of Calculus Extra Practice with Integration. And here we're going to continue working with integration by parts, doing some problems that are not really hard but can definitely lead you to, take your time through the problem to make sure you don't make an error. So let's do a definite integral, get some practice with that, from 0 to 1 of natural log of x plus 1 dx. So here's a great example of something that, it's slightly different than what we learned before, but it's different enough where you don't really know exactly where to start. So you might want to try doing integration by parts straight away. You might get somewhere with that, but really what you should do is try to simplify this integral before you do that. Before we do anything with integration by parts, let's do a substitution for what's in the center of that natural logarithm. Now usually we do substitutions, we'll say u is equal to x plus 1. But since we're doing integration by parts on these sections, it's probably not smart to use u because you'll get confused. So let's say s is equal to x plus 1. We're just picking a new variable. Then ds dx would just be equal to 1, taking this derivative. So then ds would just be dx. So that's enough information to jump out here and rewrite this integral and say, all right, well, we'll go from integral from 0 to 1 of the natural log of s, and then dx is equal to ds. So these limits of integration aren't exactly right now. I'm writing them here as a reminder to me that I need to do these, need to integrate with these limits. But it really isn't integrating from 0 to 1 anymore, because when we integrated originally it was along dx. Now that we've changed the integral to s, these limits, you can't plug it into s like that. We've done that many times. You have to convert the integral back to x in order to do it, right? So just keep that in mind. Just keep it there as a reminder, but you need to integrate this, convert back to x, and then plug your limits of integration back in. Now, how do you integrate this? This is the integral of the natural logarithm. Now, we said just in the last section that we know how to do that. We can do integration by parts, and we actually did this exact problem. We integrated natural log of x, right? And the way we did it is we said, all right, u was going to be equal to this, natural log, and dv was going to be 1, ds in this case, and then you just do integration by parts, uv minus integral v du. And we figured out that we can calculate the integral of a logarithm like this using integration by parts. Since we just did it in the very last section, I'm not going to duplicate the exact same work that we did, but what we need to note is the answer. So what we get in this case, since we're integrating s, it will be s times the natural log of s minus s, right? And we need to evaluate this from 0 to 1. We can't plug this in now because these limits are in terms of what x was, but we have our integral in terms of s because we transformed it. So really what we need to do to actually be able to finish this problem out is we need to convert back in for s. S is x plus 1, so we have x plus 1 natural log of x plus 1 minus x plus 1. And that's what we have. And we need to evaluate this from 0 to 1. All right, so I know it's a little bit ugly, but we just need to crank through it and get the job done. So what we're going to do is we'll open a big bracket, and inside here we'll have 1 plus 1, natural log of 1 plus 1, minus 1 plus 1. That's evaluating this entire thing at the upper limit, minus, here we have 0 plus 1, natural log of 0 plus 1 minus 0 plus 1. Okay? So we spell it all out because even though you can add 1 plus 1 easily, it's just, you want to make sure you don't make any mistakes.